What's up everyone? Welcome to another video. In this video, I will walk through a DIY weight plate storage rack build. This is a custom design made from steel. I will go through the design and build exactly as built, but stick around because afterward I will go over a few things that I recommend possibly doing differently, and I will also show some alternative options to achieve the same functional result without cutting and welding steel. Before we get started, be sure to subscribe for more how-to and review videos. Now let's get started. So, I was temporarily storing my plates on the floor, which was getting old. I looked at some commercially available storage racks for a quick solution, and although it would have been relatively inexpensive and fast and easy to go that route, there were several things I did not like. For example, here's the fitness gear rack at Dick's Sporting Goods. I definitely prefer to see things in person and touch them and smell them, as opposed to purchasing a surprise from the internet. When sliding the plates on, they hit the bolts. I would need to cut the bolts, or buy shorter bolts, or add rubber spacers. I just wasn't feeling it. So I got to work brainstorming some custom designs. 6 posts was a requirement, so each plate size would have its own post. I was not going to deal with multiple sized plates on the same post, requiring me to shuffle plates around to get what I needed. No thanks. Next, my preference was 2 racks, one on each side of the cage, so the plates are right there to be easily loaded and removed from the end of the barbell, without having to carry plates all over the gym from a single location. The design that I easily gravitated to was a vertical rack with 6 posts. This is the simplest and takes up the least amount of space. First, I created a template that I could tape to the wall and touch and see and make sure it was what I wanted. On a large piece of cardboard, I drew a center line and laid out the plates. I have the fitness gear plates from Dick's Sporting Goods, and the 45-pound plate is 2 inches undersized compared to standard 45-pound plates. So I spaced them with an additional 2 inches added to the diameter of the 45-pound plate in case I end up with standard size plates in the future. With the plates laid out, I traced them onto the cardboard. I used a pencil, so it's kinda hard to see in the video, but I could see it. Next, I taped it up on the wall to see it in person. With the template in place, the concept looked great to me. I work as a mechanical engineer and design complex machines for a living, so this was a fun little project for me. Here's the final design. Vertical square tube with horizontal holes all the way through, then a round tube all the way through the holes. With this design, the strength of the material supports the weight of the plates. The posts will provide maximum strength forever, with zero worries. If the posts were just butt welded, I suppose there could be concern for a post breaking loose in the future, from fatigue, after repeated dynamic loading, from loading and unloading heavy plates. The floor supports the weights of the posts and all the weight plates. The top of the post is then bolted to the floor joist to keep it from tipping forward or sideways. So the floor is supporting the weight, and the load on the floor joist is pretty insignificant. It just pins it in place so it doesn't tip, constraining it in all degrees of freedom. I do not have wall studs to screw into, and I was not interested in running anchors into my concrete wall, so this is how I handled it. For round tube diameter, I went with 1 3/4 inch OD tube with a 120 thou wall. Here is a piece of 2 inch OD tube. This is a little too tight of a fit in my opinion, and I would struggle to line them up. And here is the 1 3/4 inch OD tube. I personally like this fit. It is not too sloppy, but there is enough clearance to easily add and remove the plates. Moving on, for the vertical square tube, I went with 2.5 inch by 2.5 inch tube with a 120 thou wall. This allowed enough flat surface for the 1 3/4 inch diameter holes through the center of the face, with some acceptable clearance, considering the radiuses at the corners of the square tube. Next, I went to the local steel yard to get the materials. I purchased new steel for this project, but they sell new steel and used steel. This is a great resource for this type of project. So here we are. I unloaded the materials and was ready to get started. I have 24 holes to drill through these tubes, and the holes in the front of the tube need to be in line with the holes in the back of the tube for this to work. Using the cardboard template, I transferred the hole locations to the steel tubes and center punched them on one side. I marked the tubes together so they would be the same. With the hole centers marked, I used a 1 3/4 inch bimetal hole saw and started putting in holes. I tried to use my drill press for convenience, but it didn't work out. I put it on its slowest speed, which is 570 RPM, and also used cutting fluid, but it was too fast. The hole saw was toast after a few holes. So I bought another hole saw and hand drilled the holes. Using my variable speed drill, I was able to run it at a much slower speed and was getting nice metal chips. This worked great. And here's all the completed holes and the front side of the vertical posts. To drill an inline hole through the back of the square tube, I clamped the tube in place on the drill press, with the hole saw centered in the top hole, able to travel up and down through it with no interference or drag. When set up, I drilled through the back side of the square tube with the center bit to make a pilot hole. This was pretty straightforward and worked out pretty well. And here it is. Then I flipped the square tube over and hand drilled the rest of the holes. And here we are with all the through holes complete, front and back side, in line. Checking them with the square, most of them were in line. There were a couple that were a little off. It didn't take much for the holes to be off, which resulted in the round tube not being perpendicular. For the couple that were a little off, I used a deburr bit to ream them out a little bit, as needed. This one is now good to go. Next, it's time to install the round tube. First, I cleaned up the sharp edges and burrs left over from cutting them to length. I'm putting 1 3/4 inch diameter tube through a 1 3/4 inch diameter hole, so it's a snug fit. It turned out to be a slight interference fit, and I needed a hammer to get them through. So, this is what was desired. Everything is tight and secure, and the strength of the tubes is supporting all of the weight. The design is very strong. The round tubes need to be welded in place just to keep them from pulling in and out of the square tube. On the first rack, I tacked the tubes in 4 places around the perimeter of the front side, and planned to weld all the way around for an aesthetic look. After doing this, I changed my mind. This weld would interfere with the rubber stop washer that I planned to install, and would be undesirable. On the second rack, I welded them in place on the back side. Again, these welds just keep the round bar from moving in or out of the square tube. The beauty of this design is that the welds don't support any weight. So, these are fully assembled. Next is cleaning up edges, paint, and some finishing touches. But first, I clamped one in place in the gym and loaded it up with plates to make sure everything was as desired. Everything looked good to me, and I was looking forward to getting them finished up and installed. A few more things needed to be done before paint. First, clean up all the sharp edges. Second, drill clearance holes at the top for bolting it to the floor joist. I'm sure I could have gotten away with 1 bolt at the top with no problem, but technically, 2 bolts are required to constrain it for movement and all degrees of freedom, so I went with 2. I already had some 3/8 bolts and hardware that would work, so I used those, but grade 8 bolts are definitely not required. It's just what I had laying around. Last, oils need to be stripped from the surface of the steel before paint. I had some denatured alcohol, which will do the job, so that's what I used. Now, let's paint it. I went with Rust-Oleum Spray-On Truck Bed Liner. It is advertised as non-skid, durable, and abrasion resistant. That sounds like a valiant effort to combat weight plates scratching the paint off, but I definitely didn't expect it to stand up. I already expected that the coating coming off after time was inevitable. Here's an example of some posts that have experienced long-term use. The paint's gone. So here we are. I coated them with primer and truck bed liner, then let them dry for 4 days. And we are back, 4 days later, just about ready to install them in the home gym. First, I have a couple more items to finish them up. I wanted to install a rubber washer on the round post to prevent the plates from hitting the square post. I was not able to find any 1 3/4 inch ID rubber washers, so I decided to give these O-rings a try. Product link in the video description. Next, I have some plastic push-in end caps for all of the round posts. This is part of the reason why I went with dimensional tubing instead of Schedule 40 plumbing pipe, because nice end caps are commercially available. Product link in the video description. And last, I have some end caps for the square tube as well. I wanted them for the bottom to act as an insulating barrier between the concrete floor and the steel tube, so the tube won't rust, and to distribute the load. They are not technically needed for the top, but it was a 4-pack, so why not? Product link in the video description. And now the posts are ready to install. First, I set it in place. I decided last minute to set it on top of the foam floor, to provide some anti-slip to keep it in place. I used a level to make sure the rack was plumb. Next, I match drilled the clearance holes through the floor joist. Then installed the bolts, washers, and nuts, just hand tight. I loaded all of the plates on it to weigh it down, ensuring that all the weight was supported by the floor. Taking a look at the bolts, they can still move vertically, verifying that all the weight is on the floor, and it is not hanging from the floor joist by the bolts. The bolts just prevent it from tipping, which is a minimal force. With everything good to go, I snugged down the nuts. The last thing is to cut clearance gaps in the floor around the posts, so it's not pinned to the ground. This will allow the floor to expand and contract as needed through the seasons, without splitting or buckling as a result of being pinned to the ground. I repeated the process for the second rack. It went smooth with no issues. Match drilling through the floor joists, cleaning up my mess, installing the bolts, installing the plates, tightening the bolts, and cutting around the floor. And now they are both up and ready for action. I am very happy that I made the investment and put a rack on each side. Loading and unloading plates right onto the end of the barbell is awesome. I would definitely be regretful if I had purchased or made a single rack off to the side, carrying plates all over the place. Every time I move a plate from the rack to the bar, I feel like a VIP. Now, let's go over things that I would consider doing differently for this specific build if I were to do it over. Functionally, this is great, and I have zero regrets, but I have two things to point out. First is the wear on the posts. The paint quickly wore off the posts with the heavier plates. It has surprisingly stayed intact on the lighter plates. I fully expected the paint to wear off, so this is not a surprise or a disappointment for me. During the design, I considered plastic sleeves as wear items. 1.5 inch Schedule 40 PVC is a perfect size for a sleeve, when using 1.5 inch diameter steel tubing for the center post. However, I decided I didn't want a bunch of PVC posts sticking off my wall, and preferred steel posts with worn paint. I also considered a strip of UHMW tape on the top of the post. Since UHMW is impact and wear resistant, it is the ideal material for a wear sleeve. However, the tape is just too thin for this application. Thank you to Jason Lim for this perfect review. He tried it in this exact application, and it didn't hold up. Another option would be to use stainless steel for the round posts, and leave them unpainted, since it'll never rust. I think maybe the best option to address this is an adapter sleeve for Olympic plates. These are plastic sleeves that adapt curl bars and such from use with 1-inch standard plates to 2-inch Olympic plates. So, in the design that I built, the 1 3/4 inch diameter posts could be replaced with 1-inch diameter posts, and these adapter sleeves could be used. So, if the worn paint is something that would bother you, those are a few options. Second are the stops between the plates and the vertical bar. I used O-rings for convenience because they were commercially available and inexpensive. I suppose these will do the job, but the plate technically only touches it at the top. The bottom is able to fit inside the bore of the plate. I would prefer more of a washer, and may cut my own washers in the future. A tip for cutting nice washers is to chuck up 2 hole saws at the same time, one for the ID and one for the OD. It cuts a perfect ring. Here's an example from some PVC sheet I had laying around, but I might get some black UHMW sheet and cut some rings in the future. Now, last, I'll cover a couple options to achieve the same functional result without the need to cut or weld metal. The vertical post can be lumber. I would recommend a 4x4. There is nothing structurally wrong with wood. My personal preference was to use steel tube to match the look of my power cage and my bench. For the round posts, one option is these commercially available bolt-on plate holders. Here is a set that I have from Sill Fitness, link in the description, but they are available from plenty of other manufacturers as well. Screwing a series of these to a vertical wood post would do the job. Dimensional wood dowels should also be available at the hardware store. You will just need to bore a hole and squirt in some wood glue. And one last quick note on posts. If you want to use steel, you will not find dimensional tubing like I used at the hardware store. Plumbing pipe, which is available at the hardware store, provides options. However, you will not find nice end caps or hole saws compatible with plumbing pipe diameters. So, there are a couple additional options. I think that wraps it up. I hope you found this helpful. This was a great addition to the home gym, and I am very happy with the results. As always, thanks for watching. This was a long one, but as with all my videos, I put a lot of time and effort into it to be thorough and help you out. So, if you're still here, I sincerely appreciate it. Subscribe for more how-to and review videos. Drop any comments below, and I'll see you in the next video.